Hey everyone! So I hope that the last video kind of gave us a basic understanding of cost minimization, and so in this video we'll just go through some, I have 3 problems set up here and we'll just tackle those. So let's start off with a basic one. Here we have a production function where it's equal to 2x1 plus x2, where x1 is our labor and x2 is our capital, so we're just assuming that's L comma K. And the price of labor is $10 and price of factor 2 is $2. And so our question that we're asking is, how much will it cost for Bob to produce 16 units of output, right? So our constraint here is going to be 16 units. And how do I know that this is a cost minimization problem? We know that our end result, we should get a dollar amount, right? Okay, this is the cost we need in order to kind of have this 16 units of output, have that constraint, match that constraint. So from the previous video, to get started on this problem, on any of these types of problems, we have to equate the marginal rate of technical substitution, which really is just, our MRS, to the ratio of our labor price versus our rental rate of capital, right? So that is W over R. And what is MRS? We know already that MRS is equal to MPL over MPK. Right? So that's the partial derivative with respect to our labor over the partial derivative with respect to our capital, right? And we want to equate this to W over R. So to do these problems, a lot of times you can just use this ratio and kind of memorize your way through figuring out, okay, what do we want to focus on, capital or labor? But I just want to kind of look at the concept, okay, why are we doing what we're doing? And if we want to rearrange this just by doing some cross multiplication, you'll realize that we come to this formula, which is, if there's anything that you should remember from this video, it's this major formula, right? The one that I've written right over there in the corner. But yeah, this is what we come to, and this equation will really help us solve any of these problems, right? We want our bang for our buck, right? We want to see that the ratio of how much utility I get for the price of labor has to match how much utility I get for the price of capital, right? Knowing this, we can just start this problem off, actually. So we want to know what is the marginal, what's the derivative, what's the partial derivative of labor? Look at this equation, right? We see the partial derivative of that x, the 2x1 plus x2 is just 2, okay. And our labor price is, we already know, it's factor 1, right? Because this corresponds to, the 2x1 corresponds to this price. So that is just $10, okay. And then the partial derivative with respect to k, which is just x2, that's just 1, right? Because that's the coefficient. And r is our $2, right? So clearly we can see that that this is not equal. So we know that this is not equal. We should not be producing equal amounts of that. So there's obviously, Bob is better off focusing on either capital or labor. And how do we know which one they should focus on? Well, clearly 1/2 is greater than 2 over 10. So we will choose this one. Bob should choose capital to focus on, right? Because he's better off, his bang for his buck, like he's just better off focusing on capital. Now, how do I proceed? We should focus, okay, so when we're looking at this is our constraint, right? 16 units of output. How to better write this is that I want to make sure that my production function has 16 on the right side, like this is equal to 16. And then we have 2x1 plus x2, right? Now, I already said I am not focusing on labor. I already said I'm not focusing on the 2x1. We're just going to ignore that, right? Bob should not be producing. Bob should be producing 0 labor, And we are left with 16 is equal to x2, right? So we know that Bob is not producing any of x1, and Bob is only focusing on x2. So then, if we just look at if we use a graph, we'll see that if this is labor and this is capital, we'll know that Bob only produces capital, only focuses on capital. And knowing that, how do I go back to my cost function? All we have to just do is multiply this by how much how much capital costs. So this would be 16 times, how much does it cost? $2. Oh, so that's $32. All right, so let's do the same thing, but with a different result. Again, I'm going to write out my handy dandy formula, right? This is it. And I know that the price of the first factor is $2, which is our labor, and then the price of the second factor is 3. How much will it cost for his firm to produce 20 units of output here, right? Now I know that my MPL, again, this is our labor, right? This is our labor, this is our capital. We're just assuming that. I know that the partial derivative with respect to L is 4, and I know that the wage is just $2. And here I know that the partial derivative with respect to K is 5, and then this is $3, right? Which is larger, 4 over 2 or 5 over 3? Oh, I know that I get more utility for producing just labor when we're just focusing on labor. So Bob should just focus on labor here. Okay, knowing that, let me write my equation, right? I know that this is my constraint. I know that I want to produce $20. I want to produce 20 units of output. Now, how much will it cost for me to produce that? So I know that the production function should have 20 is equal to 4x1 plus 5x2, right? But like I said, we are kind of ignoring the capital. I don't care about capital. I'm not going to get that much utility. Just focusing on that. So what is 4x1 is equal to 20? What is x1? I know that x1 is going to be 5. And to find out the cost, I'm just going to multiply the price times how much I'm going to be, how much of this. So it's just going to be price is $2 times 5, and we should get $10 as our cost. And that's the answer to this one. So now we have a new problem. We have a new production function, and this is a complement function, right? So here we'll focus on the same thing. I think these types of problems are much easier because you're just equating the two, right? How to solve this one is, okay, again, I know that my production function has to have this as our constraint, right? So I know that this is what it is. But it's a minimum of either the labor or either the capital. So what I do to solve this problem is just equate. It could either be this, or it could either be this, right? So now all you have to just do is just solve for 1 and 2, and then just see what the cost will be, right? It'll be either the minimum of this and that. So I know that this is, oh, I should use a different color. This is going to be like 120 divided by 2, so x1 is going to be our 60, and for this, x2 is going to be our 40, right? And all I do is just multiply, okay, how many units of labor is Bob going to use? How many units of capital is Bob going to use? And then the cost of each. So this one is really, really easy. All you have to just do is equate the two, right? Plus 40 times 10, right? So that's going to be 300 plus 400, and that should give us $700, right? So that should be, I should write this more neatly. I'm so sorry about my handwriting. Yeah, so how much will it cost to produce? $700 to produce this. This one's much easier. You just equate the two because I know at the end of it that 2x1 comma 3x2 should be equal to each other, right? To find the proper production function. So yeah, I hope that this helps. Just the only way to kind of practice and learn through this is to have more practice problems. So just focus on these, change up the numbers, and work on them yourself. So thank you.